Okay, so we are going to continue from where we stopped yesterday. So yesterday we stopped at question number 28, isn't it? Okay, so 29 we did not manage to finish discuss, so I'm going to start from there. Okay, so 29 sounds like this. The standard enthalpy change of the combustion for boot 1 in C4H8 is x kilojoule per mole. Standard enthalpy change of the reactions 2 C2H4 gives C4H8 is y kilojoule per mole. So what is the standard enthalpy change of combustion for ethene C2H2? Okay, so now you have to write the combustion equation for the butene, put one in. So the combustion equation for the butene can be written as C4H8 plus 6O2 give 4CO2 plus 4H2O. So this is X. So this has been given as the enthalpy change of combustion. Okay, enthalpy change of combustion. So okay, then the next one is the combustion for the next one is Y. So 2C2H4 give C4H8 lah. So we can start to cancel off among each other already. Okay, so which one and which one can be cancelled? If you notice carefully, C4H8 can cancel with C4H8 already, isn't it? So at the end of the day, what you left over is 2C2H4 plus 6O2 give 4CO2 plus 4H2O. So in here, the summation is X plus Y, isn't it? But in this case, it is still 2. If you notice carefully, okay, it is still 2, isn't it? Because our standard must be how many mole? Must be 1 mole. So everything in here, you must divide by 2. So your final answer, what is your best one? Your best answer in here is C. Okay? The best answer in here is C. Okay, so that is for question number 29. Okay, so immediately we move to 30. Which of the following element has the lowest enthalpy change of the vaporization? So vaporization means that from liquid to become gas. Okay, so among them, this one is a very common knowledge. So the one which has the lowest enthalpy of vaporization is argon because it's already a gas. Okay, so therefore it has the lowest enthalpy change of the vaporization. Okay, so 31. Which equation shows the reaction that occur during standard enthalpy change of atomization of bromine? So don't forget that bromine exists naturally as a liquid. Okay, so for atomization of bromine, it changes from half Br2 liquid to Br2 gas. Okay, atomization to form 1 mole of Br. So the best answer in here is C. Then 32, which of the following enthalpy change can be positive, negative? Which row shows the correct enthalpy change? Okay, so in here we are going to straight away expose what is the atomization for each of them, and then from here we can this one. So atomization is positive. Okay, endothermic can be atomization, bond fission. Bond fission is bond breaking. Okay, series of ionization energy, second electron affinity, and enthalpy change of the solution can be endo, can be exo lah, isn't it? Then for exothermic, it can be formation, combustion, neutralization, first electron affinity, lattice energy, hydration, and also solution. Okay, so these are the possible endothermic and exothermic of the reaction. So from here, we can tell that the one which are positive can be 2 answers. The answer is either B or C. Okay, B and C are both accepted in this case. Okay, because if you look carefully, in B, bond fission is bond breaking, so endothermic. And then C, first electron affinity, first ionization energy and first electron affinity lah. So the answer can be B and C. 2 answers in here. Okay. Okay, so this is 32. 33. The equation for the complete combustion of propan 1O is shown below. Standard enthalpy change of the formation is given below. Which of the following could be the enthalpy change of the combustion for propan 1O? So this one you can use total enthalpy change of the product minus total enthalpy change of the reactant. So straight away apply to the formula. 3 times CO2 plus 4 times H2O minus negative 303, which is the formation for the propan 1O. So press your calculator, you get your answer as 2023. Okay, very straightforward answer. Okay, so that is for question number 33. Then we go to number 34. in calorimeter experiment, 1.6 gram of fuel are burned to are burned. So 45%. So in here, only 45% of energy is released, absorbed by 200 gram of water. So the temperature rise from 18.0 to 66.0 degrees Celsius. What is the total energy released per gram? So now we are looking per gram. So no need to do until per mole. So you just simply at the end of the day divided by 1.6. But don't forget that our efficiency is only 45%. Okay, our efficiency is only 45%. So later you have to time 100 divided by 45 to get the full one. Okay, so this is the solution. First, you use Q equals to MC theta. So you substitute 200 gram of water, 4.18 heat specific capacity of water, final temperature minus initial temperature, 66 minus 18. So you get your Q equals to 4128. So in here, 4128 divided by 1.60 gram. So the efficiency, don't forget, is 45%. So if you 100%, so you have to time 100 divided by 45. So at the end of the day, the heat per gram in here is 5570 joule, not kilojoule, typing error, sorry for that. 550 joule, not kilojoule. Okay, typing error. Okay, so the answer in here is B. 35. An important reaction of the manufacture of nitric acid in the catalytic oxidation of ammonia is given here. So for every mole of O2, look carefully at the question. For every mole of O2, 181.8 kilojoule is released. A factory that makes 2.50 times 10 power of 5 mole NO every day. How much energy in kilojoule is released every day? Okay, so in here, it sees that 1 mole releases 181 kilojoule. So in here, 5 mole of oxygen will releases 909 kilojoule. So since the reaction represents the whole combustion process, therefore, for ammonia, from 4 nitrogen monoxide, 4 to 4, that means 1 to 1, isn't it? So the mole ratio in here is 2.5 times 10 to the 5 mole of NO is produced. So hence the production of the reaction per day, because you burn 5 oxygen to produce 4 NO2, okay? So in here, and then take notes that in here is kilojoule, not kilojoule per mole. So we don't have to divide by 4 times 5, because in this case, we want the overall 4 kilojoules in here. So straight away, 909 multiply by 2.5 times 10 power 5. So you get 2.27 times 10 power 8, which is the D as the answer. Okay, so I hope that you can understand what is it going on in here. Okay. Okay, so this is for question number 35. Immediately we go to question number 36. The enthalpy change of the reaction 1 is 2 NaOH plus H2O give Na2SO4 is reaction 1. By using this information, what could be the reaction of the enthalpy change for reaction 2? BaOH plus 2HCl give PaCl2 plus 2H2O. If you notice carefully, in the reaction 1, this is neutralization. Okay, if you notice carefully, this is neutralization to form 2 water. 2H2O. So in here, you also form 2H2O. So what is the answer that you are supposed to get in here? It's supposed to be the same, isn't it? So it's 114 kilojoule per mole. Okay, so that is for 36. Okay, any questions so far? Okay, so hopefully no problem. Okay, 37. Enthalpy change of combustion can be used to determine the enthalpy change of the reaction for the as represented by the following enthalpy. 4C plus 5H2 gives C4H10. By using standard enthalpy change combustion data, what is the value of enthalpy change of formation for butane? Okay, so in here, you can use Hess law. You can also use you can use Hess law. Hess law is always the best way to solve. So this one I already straight away manipulated the equation. So you have 4C plus 4O2 give 4CO2, negative 394 times 4. 5H2 plus 5O2 give 5H2O. So negative 286 times 5. And then this one is the reverse combustion. Reverse combustion. So you can start to cancel off among each other. So for example, you can cancel 4CO2 with 4CO2. 5H2O cancel with 5H2O. Then the total oxygen 4O2 times 5O2. Okay, you can straight away cancel already. Leave 13 over 2 over 2. So at the end of the day, you have 4 Sorry, typing error. 4C plus 5O2 give C4H10. Yeah, never mind. I'll just play along with it. Sorry, I'm typing error. Okay, so in here I'm going to correct on here. So you have 4C plus 5H2 give C4H10. Sorry for my mistakes in here. Okay, so you get negative 129 kilojoule per mole. Okay, so the answer in here will be B. Okay, okay, so this is for 37. Then it goes for 38. Anhydrous copper 2 chloride CuCl2 combines with water to form CuCl2.2H2O. Standard enthalpy change of the formation for these reactions are shown below. So you have CuCl2 solid negative 206, H2O negative 280, and the complex formation is negative 808. What is the standard enthalpy change for the reaction below? Okay, so in here you can straight away use total enthalpy change of the product minus total enthalpy change of the reactant. So negative 808 minus negative 206 plus negative 2 times negative 286. So you get enthalpy change of reaction is negative 30 kilojoule. Okay, so the answer is not KD. Very straightforward. Huh? Okay, then we have question number 39. Which statement helps to explain why calcium and chlorine form CaCl2 rather than Ca2? Okay, so in terms of the enthalpy change of the formations, enthalpy change of the, in terms of the formation of CaCl2, we are usually looking at the lattice energy. Okay, we are looking at the lattice energy more because both of them are ionic compounds. Okay, so it seems that the enthalpy change of the lattice energy is more exothermic than CaCl2. How can we say like that? If you remember the formula, lattice energy is equals to the enthalpy change of the formation. Okay, minus of everything for atomization of the calcium. We have atomization for the chlorine. Okay, we have the first plus second ionization of ionization energy of the calcium. Okay, first plus second. And then last but not least, you have the electron affinity times 2. Okay, this one also times 2 of the Cl in here. Okay, so because you have more atoms to be involved in the reactions in here, so it is expected that the lattice energy is going to be more exothermic compared to this one. So as a result, the lattice energy is more of CaCl2 is more exothermic. Okay, so the best answer in here that describe everything is C. Okay. Okay, so that is how we explain why calcium and chlorine form CaCl2. Okay. Okay, so that is for question number 39. Okay, straight away we goes to the question number 40. Okay, so enthalpy change of the reaction between calcium and water can be measured in laboratory below. What information other than obtained in this experiment is needed to calculate the enthalpy change of formation for CaOH2? Okay, so now you want to calculate the enthalpy change of formation for CaOH2. So you will need the following information. You can in here, let's have a look one by one of the option. So in here, do we need to calculate enthalpy change of atomization of the calcium or not? The trait goes like this. The trait goes like this. Sorry. Okay. Okay, so Ca plus 2H2O give CaOH2 plus H2, isn't it? Okay, so if you want the atomization of the calcium, okay, so if you want the enthalpy change of the atomization of the calcium, no need, okay, You want the first and second ionization of calcium, also no need. The Lattice energy also no need. Okay, so in here we only need the enthalpy change of combustion for the hydrogen, because hydrogen can change to H2O lah. So this is a very direct questions. Okay, that tries to tells you that if you want to find the enthalpy change of the reaction above, because at the end of the day, when hydrogen burn, okay, you form H2O mah, isn't it? Okay, so you want to get the enthalpy change of the formation for CaOH2. So if let's say this is X, okay, so enthalpy change of formation X is equals to total product minus total reactant, CaOH2, okay, minus of enthalpy change of the formation for H2O lah. Because this one, enthalpy change of formation is equals to 0. This one is enthalpy change of formation also equals to 0, isn't it? So that is how you can get the equations in here, okay? Okay, so with that, that is how you solve all the 40 objective questions for chapter 1. So I hope that my explanations helps you to understand better on how to solve the 40 questions. Okay, so without hesitation, let's straight away move on to the section B, which is the structure question. So I hope that you already do your homework already. Yeah? Okay, so are you ready? Let's move on to section B. Okay, so section B sounds like this. Sulfur is one of the most abundant non-metal on Earth. It can be found in the form, it can be found in the form of calcium sulfide. A, write a balanced equation to represent the following standard enthalpy change of the reaction. Number 1, standard enthalpy change of the formation for calcium sulfide, CaS. So in here, very straightforward. Because calcium is solid, sulfur is also solid. You can also write 1/8 S8. It doesn't matter. Okay, so it's the same. So you form CaS in form of the solid. Okay, teacher, how do we know that CaS is a solid? Because when it is when it is in the form of the ore, okay, so it's usually a solid ore, okay. Okay, so this is how we write enthalpy change of the formation for CaS. Number 2, enthalpy change of atomization for CaS. So CaS atomized, that means it will become calcium gas and also sulfur gas. Okay, so state of matter is a must. So you must write out the state of matter and then balance the equations. Okay, so that will be how you solve for number 1A, 1, 2. Okay, B, calcium sulfide burn in air to form calcium oxide and sulfur dioxide. The enthalpy change of the combustion for calcium sulfide can be calculated using Hess law. 1, define Hess law. So what is Hess law? So if you still remember, I always stress that whenever you define Hess law, you must have 2 keywords. What are the 2 keywords? Number 1, enthalpy change of a chemical reaction is the same. Then number 2, regardless of the route taken, or no matter it is one step or series of steps, also can. Okay, so try your best to remember the 2 keywords of defining Hess law in here. So this is for B1. Okay, and then B2, given standard enthalpy change of the formation for calcium sulfide, calcium oxide, and calcium sulfur dioxides are -328, -1063, and -294 respectively. Calculate the enthalpy change of combustion for calcium sulfide. Okay, so first of all, definitely you need to write the combustion of the equation for the calcium sulfide first. Only then you need to know how to apply, isn't it? So in here, and it is always better if you use the Hess law method to solve. Okay, so I would usually recommend students to write slowly one by one, not straight away jump to this one. I'm so sorry because I straight away jump to this one. Okay. Okay, you try your best to write in terms of the enthalpy change of the reaction one by one. What do I try to say in here is, you can first write calcium solid plus sulfur solid. Okay, give calcium sulfide. Okay, solid. Okay, so enthalpy change of the formation is equals to negative 328 kilojoule per mole. So try your best to always practice the habit to write the equation before you solve the Hess law one by one. Okay. So enthalpy change of formation is equals to negative 1603. And then you have sulfur dioxide, sulfur solid plus O2, SO2 gas. So delta HF is equals to negative 2. Okay, so always try to write this first. Only then you start to manipulate. So how do you manipulate? So you reverse the calcium sulfide. So CaS gives Ca, enthalpy change of formation is positive 328. Calcium sulfur solid plus half oxygen give calcium sulfide negative 1603. And then sulfur plus oxygen give SO2, enthalpy change is negative 294. So you can start to cancel between things already. So what you can cancel? You can cancel, let's say calcium and calcium cancel, sulfur and sulfur cancel. Okay, so as the overall result, you will get calcium sulfide plus 3/2 O2 with calcium oxide plus sulfur dioxide, and enthalpy change of the combustion is negative 1569. So usually I would advise students to use Hess law to solve. It is the best methods to score in the structure and essay. Okay, teacher, so can I use the total enthalpy change of the product minus total enthalpy change of the reactant? Yes, you can. Okay, you still can use that formula, but sometimes they don't give the maximum marks. Okay, so they will. But in this case, 4 marks is very easily predicted. First of all, you must write the combustion equation for the reaction. Ca solid plus 3/2 O2 gives CaO plus SO2. Then you use total product minus total reactant, so substitute accordingly. Negative 1603 plus negative 294 minus negative 328. So enthalpy change of combustion is negative 1569 kilojoule per mole. Okay, so no matter what methods you use, the answer will still be the same. Okay. Okay, so with that, that is how you solve for question number 1. Okay, immediately we go to question number 2. Okay, question number 2 sounds like this. Liquid hydrazine N2H4 is often used as a source of fuel in the enthalpy change of combustion. Is very exothermic. The thermochemical equation for the combustions of hydrazine is shown below. We have N2H4 plus O2 give N2 plus 2H2O. So enthalpy change is negative 562 kilojoule per mole. So 1.50 gram of the hydrazine is burned in the bomb calorimeter. Calculate the temperature change if the total heat capacity of the bomb calorimeter is 6.02 kilojoule per Kelvin. Okay, so now you want to find what is the temperature. So you were given the enthalpy change is negative 562, isn't it? So you have to use the 3-step method. So what is the 3-step method? First, you calculate, first is Q equals to C theta or Q equals to NC theta. But because in this case, we have kilojoule per Kelvin, so you must know by yourself that you use Q equals to C theta. Okay. Then number 2, you calculate the mole is equals to the mass over the molar mass. Okay. And then last but not least, delta H is equals to Q per mole. Okay. So in this case, it's a reverse step. So that means you use delta H and mole to calculate Q, and then from Q you calculate the theta. Okay, so what is the mole of the hydrazine? So mole of the hydrazine is negative 1.50. So substitute as exactly given to you in the questions, including substituting the relative atomic mass. So you must substitute as exactly given in the periodic table at the behind of your notes. So 1.50 divided by 2 times 14 plus 4 times 11. So at the end, you get more. Then enthalpy change of the reaction, Q is equals to delta H multiplied by the mole. So you get 562 kilojoule multiplied by 0.04688. Okay, and finally, theta is equals to Q over C. So you get 26.3 kilojoule divided by 6.02 kilojoule per Kelvin. So you cancel kilojoule. At the end, you get your temperature, 4.38 Kelvin. Now, take notes of the units of temperature because they give in Kelvin. So your final answer should also be in Kelvin. Okay, because it doesn't really matter. Changes in 1 Kelvin is also equivalent to changes in 1 degree Celsius. So don't mind too much about whether you use degree Celsius or you use Kelvin. But at the end of the day, you just follow whatever questions give the unit to you. Okay. Okay, so that is for question number 2A. Immediately we go to question number 2B. Question number 2B sounds like this. Calculate a standard enthalpy change of the hydrazine if the formation of the water is water vapor. Formation of water vapor is negative 242 kilojoule per mole. Okay, so first you write the formation reaction of the water. Okay, so 2H2 plus O2 give 2H2O, so you get negative 242 times 2. Now, in this case, if you notice carefully, hydrogen is gas, oxygen gas, water is vapor, so it must be in gas. In our normal equation, we write water as liquid, isn't it? So in this case, it's gas because the question already specifically says it's for water vapor. So you multiply by 2, and then you substitute the reactions above in here. Okay, so N2 plus 2H2O give N2H4 plus O2. So now you can start to cancel in between things already. So which one can be cancelled? You can cancel O2 with O2. You can cancel 2H2O with 2H2O. So at the end of the day, what do you use? What do you get? So you get N2 plus 2H2 give N2H4, and W change of formation is positive 78.0. So if you notice carefully, all of the enthalpy change have a 0.0 behind here, 9562.0, 242.0. So in here, your final answer must also have 0.0 behind your back here. Okay, teacher, what about the substitution part? Do we have to substitute the unit? Actually, in substitution part, you don't need to substitute the unit. You just need to substitute the exact figure given to you in the question. That is more important than the unit. Okay, so you don't write unit also, never mind. Okay, but then the final answer, kilojoule per mole, the unit must be written in here. Okay, so and then positive sign is also a must. Positive sign is also a must. A lot of students tends to neglect the positive sign, even though the value after you press your calculator is does not write the positive, because usually people don't write positive, isn't it? But for standard enthalpy change, positive negative sign is always a must whenever you try to write. Okay. Okay, so and then as I always tells you, no matter what equation that you solve, Hess law is always the safest methods to use whenever you try to solve for structure and essay. Okay. Okay, so that is for number 2. Okay, immediately we move to number 3. Okay, number 3 shows like this. Born-Haber cycle may be used to calculate the Lattice energy of potassium oxide. So this is the Lattice energy, Born-Haber cycle. So let's together understand what does H1 until all the H represent in here. Okay, so you must know that H6 represent what? So 2K plus half O2 give K2O. So H6 is enthalpy change of the formation. Then H1, 2K, what is the changes that you can see in here? So on here, you can see that it is how solid change to become gas, isn't it? So this is enthalpy change of atomization for potassium, okay? And then from H2, 2K become 2K plus, isn't it? Okay, 2K become 2K plus, okay? So this is the ionization energy. And because there is 2, so you must multiply by 2 lah. And then number 3 already tells you that this is atomization, and this is definitely atomization for oxygen, okay? Because you change to O. So what is the equation A? So later you need to figure out. And then enthalpy change of 4 is from how oxygen become O2 minus. So you have to know by yourself that it is the summation of the first plus second electron affinity. Okay, it is the first plus second electron affinity for the H4. And then finally, this is the lattice energy. Okay, So after we already get clear of how each of these cycle works, then it is easier for us to solve the questions already. Are you ready? Okay, number one, name the following enthalpy change in the cycle. So as we mentioned just now, H1 is the enthalpy change of atomization of potassium. H2 is the first ionization energy of potassium. H6 is the lattice energy. Okay. And H6 is the enthalpy change of formation, sorry. H5 is the lattice energy. H6 is the formation of the K2O. Okay. Okay, B, using data booklet, calculate enthalpy change of the hydrogen, H2. So H2 is not hydrogen, H2 is the behind the, following the diagram in there. So you can refer to the data booklet, which is to the behind. Actually, nowadays, Stpm, they won't ask you like this anymore because in the old syllabus of Stpm, they will give you the data booklet, which you can find behind the books. What is the ionization energy for potassium? Okay, so I'm so sorry, I modified from the past year questions. Okay, so you find the value from the data booklet. So H2 is 2 times positive 418, and then answer is positive 836. In here, you must insist the positive sign, and the unit must be kilojoule. Cannot write kilojoule per mole. Why cannot kilojoule per mole now? Because you have 2 potassium. So 2 potassium, that means the enthalpy change must be kilojoule only, cannot be kilojoule per mole. Okay. Okay, C, write the equation in A. So A is the, as we mentioned just now, is the atomization of oxygen, isn't it? Okay, so your equation must contain 2K plus gas plus O gas plus 2E minus. Okay. State of matter is a must, of course. In this chapter, thermochemistry, state of matter is always a must. Okay, and then they use your cycle to the following data further from the data booklet to calculate a value of lattice energy. So as we already discussed, lattice energy is equals to enthalpy change of formation minus total enthalpy change. You have 214 plus 836 plus 248 plus 620, so you get negative 2285 kilojoule per mole. In this case, teacher, do we need to look out for the significant figure or not? Actually, no need to look out for significant figure. You only look out for significant figure when you involve calculations that applies together with the symbol, the formula, like Q equals to MC theta, mole equals to mass over molar mass. That one you have to follow according to the significant figure. But in the case of plus minus the enthalpy change, then no need to follow the significant figure. However, you need to be careful in terms of whether the question have 0.0 or don't have 0.0 at the back. If you notice carefully, all the cycles in here have 0.0, right? So your final answer must also have 0.0. Okay, so that is what I want you to take notes whenever you are answering for such type of questions. Okay. Okay, so that is for number 3. Okay, with ionization, let's move on to question number 4. Question number 4 sounds like this. Ethanol, C2H5OH, is an important industrial chemical. It is used as a solvent, a fuel, and also intermediate in large scale of organic synthesis. A, define standard enthalpy change of the combustion. So always remember how to define the enthalpy change. So enthalpy change of combustion is the heat released when 1 mole of substance is burned completely in oxygen, okay, under standard condition, okay. If you are worried here, you might also want to write a thermochemical equation for the combustion, but in here, no need, because B, write a balanced equation to represent the complete combustion. So definitely in here, the marks goes to the complete combustion. So C2H6O plus 3O2 give 2CO2 plus 3H2O. And then in combustion, the water must be in the form of gas, okay. So try your best to write like that, okay. Okay, then C, 1.00 gram of ethanol was burned under a beaker containing 100 grams of water, raising its temperature from 50 degrees Celsius to 65 degrees Celsius. The process was known to be only 70% efficiency. Okay, so in here it is 70% efficiency. Calculate the enthalpy change of combustion per mole of ethanol. Okay, so after you calculate the heat transfer or heat change, because it's only 70%. So later, when you calculate Q, Q you have to time 100 divided by 70 so that you can get the 100%. Understand? Okay. So this is the tricky part of these questions. So you still use the same 3 steps. Q is equals to MC theta. Then delta Q mole is equals to mass over molar mass, and then delta H is equals to Q per mole. Okay. So how do we solve this question? So first, Q equals to MC theta, or 100 times 4.18 times 65 minus 15. Then mole of ethanol 1.00. Substitute as exactly given to you in the questions. So if the question give you 1.00, your substitution also must be 1.00. Okay, divided by 2 times 12 plus 6 times 1 plus 16. And finally, delta H combustion. So 100% times 70 multiplied by 20.9 kilojoule times 166, you get 1373. Okay, so that is how you solve your question. Sorry, I'm going to correct this. It should be 1370 0. 3 significant figure. 1370. 3 significant figure. Unit kilojoule per mole. Okay, okay, so that is how you solve for number C. Okay, we have one more question, which is D. Are you ready? Okay, so based on the answer in the C, calculate the enthalpy change of formation for ethanol given the combustion of carbon and hydrogen is negative 393.5 and negative 286.8 kilojoule per mole respectively. Okay, so in here, the best way is still use the cycle. So such question is a consecutive question. That means if your C is wrong, automatically your final answer for D will also be wrong. So in here, they are very straightforward things. So you have to be careful whenever you're calculating for your answer in here. Okay, okay, so how to solve? So first, delta HF, you can use a total enthalpy change of the product minus total enthalpy change of the reactant. No. Can I cancel this? Okay, so in here, it is always the best if you use Hess law to solve. So in here, you write C plus O2 gives CO2, okay, and then H2 plus half O2 give H2O. I always advise students to use Hess law. Sorry, because my answer scheme can be sometimes quite complicated. And then the combustion C2H5OH plus 3O2 give 2CO2. So you get just now negative 1370. Okay, then because you want to find the formations, okay? So in here, carbon multiplied by 2, hydrogen multiplied by 3, and then this one you have to, no need this one no need to do anything, just follow. So then after you do the manipulation, I'm only going to straight away do for this one only. So you get CO2. So you get negative, so you get the answer. 393 times 5, you get negative 787.0, and then 3H2, 3O2O2, give 3H2O, you get negative 4, 2, 0, 2. Help me, Mr. Chu very slow. Okay, you know by yourself. Okay, later you solve. Okay, you can start to cancel things already. So this one you have to reverse. Reverse. Okay, so you get 2CO2 plus 3H2O give C2H5OH plus 3O2. Okay, so you can start to cancel already. 2 CO2 cancel with 2 CO2 cancel with 2 CO2, 3H2O cancel with 3H2O, and then 3O2. Okay, so you get half O2 left. Okay, cancel with 3O2 So you at the end of the day,